I'm pleased to be introducing the next speaker who will be joining us, Bruce Fulford. And one point I'd like to make in introducing Bruce is, as Bruce will be talking about building up soil, something that I found a bit confounding as I got involved with this work is that periodically I would see estimates of how long it took to build up an inch of soil. Perhaps you've seen these as well. The estimates that are published that you can readily find say that it takes anywhere from 200 years up to, I've seen, as long as 1,000 years to build an inch of soil. If we have any hope of taking the carbon from the atmosphere and putting it back into the soils, then a rate of building an inch of soil in 1,000 years is not acceptable. It has to be done faster, and in fact it can be done faster, and it is being done faster than that. The 200 years to 1,000 years refers to physical weathering of the rocks and not bringing biology into the picture. When we bring biology into it, then soil production can happen much faster, and this is the reason why we're so hopeful and optimistic that so much of the atmospheric carbon can return to the world's soils. So speaking to this, Bruce Fulford, very happy to have him here this morning.
Hi, good morning. Well, I'm personally responsible for a whole lot of erosion, having made dams and studied the effects of water on mud and washing topsoil downstream. I loved doing that as a kid. But my father informed me and my 5 siblings that it's really not the way to do it. He worked during World War II planting trees and mitigating the effects of soil erosion, amongst other things, and instilled in us an ethic that we really should be building soil and not washing it away. But I grew up in an agricultural community, and I have lived in Boston for some reason for the last 25 years. So I'll talk largely about Boston and the experience in the watershed that I work within and live within. My company, City Soil and Greenhouse, runs the City of Boston's composting operation under contract, and that is on the grounds of the Boston Nature Center in Mattapan, which I'm told means a nice place to live. I don't know the language other than that. This slide here shows the former Boston State Hospital patches of tan here were stripped off of contaminated soil, which was exported, and new soil brought in to cover that and build the Nature Center and housing developments, which are still under construction. Mentioning the soil erosion that I was inculcated with as a kid, it bugs the shit out of me whenever I see it. It infuriates me, and I see it all too often in practices that are engineered, designed, and implemented with our money as taxpayers and residents of the planet. So much of the work that I've been doing in the last 30 years is focused on composting and trying to rebuild soils in an effort to fast forward that practice that usually takes thousands of years. Seems like composting is where I landed as a way to remediate those problems that we are creating as humans. I got pretty fascinated with the biology of composting because of the heat factor. I thought it was really, really cool. And one of my older brothers, who some of you probably know, Mark, we went away on vacation one summer, and he was really pissed off because he was in the middle of making compost in 14 days. He got a hold of a Rodale book that said, you can make compost in 14 days, and he couldn't be there to turn it. But from him and from others, that's been my profession, is how do you make compost faster, better, cheaper, more efficiently, and but that heat part stuck with me. And at one point, fairly early in my profession, I designed a greenhouse system at the new Alchemy Institute that used the heat of composting to heat the greenhouse, but also give off carbon dioxide and capture the CO2 in the greenhouse atmosphere to boost photosynthesis. Old practice used French hotbeds around Paris. This was the way they did it. They didn't do it in large greenhouses. But I thought it was really slick. And I thought let's take this old system, juice it up with small blowers and intern labor. Always good to have interns. And this composting system was a fairly self-contained, bio-powered driver of production. That's one lettuce that weighs about a pound, and that grew in a growing bed inside the greenhouse, directly in the soil that filtered out that heat and trapped the CO2 in the plants. And so since that time, that was the early 1980s, I've been implementing various forms of that integrated with the composting systems on a commercial scale or municipalities over the years to try and implement the more large-scale composting, not just small greenhouses, on a research institute. Part of the work where I look at carbon farming is what we're supposed to be talking about. I look at the impacts of my industry, composting, in fossil fuel use. So try and make compost with less fossil fuel and make mulches and products that are amending the soils if the process that they're made with releases massive amounts of carbon dioxide from fossil fuel. It doesn't work out so well. So I early on adopted composting techniques and equipment that I thought per ton of compost produced yield required the least fossil fuel possible. We had an Amish-made compost turner that was propane powered in 1999. We had a half-mile long windrow of compost snaking through Franklin Park Zoo. The Guinness Book of World Records did not have a category for the longest windrow, but we might have been a contender at that time. Other projects that I've worked on and are still trying to implement and implementing in certain areas are composting of the organic fraction that comes out of the urban environment. And we did composting of food waste, cardboard, and that was collected at the Haymarket and brought it to Allendale Farm in Brookline and composted it there, and using fairly inexpensive off-the-shelf equipment. The composting work that we do now at the City of Boston's composting site started out on a paved area that used to be the former Boston State Hospital. And what at that time was a fairly modest operation, now we manage about 50 times the volume that you see in this picture. Plenty of landscape organics. There's about 25,000 cubic yards a year that land on residential properties in Boston are collected and then brought to our composting site. One of the projects that we've done with the products that we make is to use the finished compost and blow it on slopes to prevent erosion. So we're trying to not just make compost for community gardens and growers, but have it used in the landscape and influence hundreds, if not thousands, of acres in our watershed. Our footprint in the composting site is less than 4 acres. Of that, close to 3 are in production of compost, and then there's a buffer zone around it. We do use fossil fueled equipment. We try to minimize it, but here you see the steam that's being liberated by the composting process. We're starting to include food waste, not at this site. There's now a ban on food waste disposal that recently was implemented in Massachusetts, first of its kind. And we hope to be composting food waste at the City of Boston's composting site. We need more lobbying support from people that are more expansive thinking than the Public Works Department. But we have the legislative authority, but not the contract in place that allows us to do it. This is an overview of our site. It's on the bordered by wetland. This is really a storm drain that leads eventually into the Stony Brook and the Charles River. And our intent is to manage the buffer zones around the composting site and use them agriculturally, and use them to capture runoff, to utilize the heat that comes off of the composting process, and to grow crops that are either non-invasive, which we have many, beneficial crops for food production, for stormwater capture, for revegetation of riparian areas, which are all in this very damaged urban landscape. This is a German piece of composting equipment that really fun to drive, I got to tell you. But takes about, it's like a combine. It straddles over the compost, kicks up the material, blends it very well, and uses about 1/5 of the fuel that a front end loader does for the composting function. Some of the products that we've made have been used, soil blends, to make new urban agriculture possible for the Food Project, for the Urban Farm Institute, and are used by the Boston Natural Areas Network throughout the city. So we've delivered to more than 150 gardens and urban farms over the course of our work. Greenhouse production mixes. We did a compost-heated greenhouse at the Revision Urban Farm, where we composted a lot of dead fish. Growing tilapia is a tricky business, and so there are a lot of mortalities. But we took those mortalities and turned them into very rich compost, and also heated the greenhouse with manure and leaves that we got from the Parks Department. So in an intensely populated urban area, it is possible to make good compost, not piss off your neighbors, and have systems that rely very little on fossil fuel to be operating effectively. We worked with a number of different growers, as I mentioned, Parks Department, and with a developer of a portion of the old Boston State Hospital, which is more than 100 acres, and brought in new soil. So we blended the soil, and we used materials that we got from the local cemetery. Every time a grave is dug, clean subsoil is brought up, a coffin is put in. We take that clean subsoil and blend it in with clean compost that we make from leaves and yard waste. So how do you make an inch of topsoil in less than 1,000 years? Get it from the cemetery and get it from the trees. It's a different kind of carbon farming than you might have been doing. But, clean soil is at a premium in the city. So finding clean sources close in to the city is that's our secret. And the rest we have to bring in, some of the components we have to bring in from outside of the city. We've worked with federal and state funding to try to enhance numerous acres. So again, this is one project was more than 40 acres around the Boston State Hospital. And our objectives were to enhance the soil quality and content so that it would trap nutrients, trap water, reduce the pollution that was flowing off of the construction sites. So on large scale, we do that kind of work, big trucks, lots of heavy equipment, and judiciously applied, and also workshops with more human-powered. This is a compost heating system that the Boston Natural Areas Network hosted a workshop. So we crammed in as many humans and wheelbarrows as we could to make this little compost-heated hot bin inside a small greenhouse. The fascination with the heat production is something I have mentioned. A cubic yard, 3 by 3 by 3 of compost can give off about the heat of 10 gallons of oil as it decomposes. The systems to capture that and use it effectively are various, some more effective than others, but it's a significant enough amount of energy that with the right system in the right place, compost heating can be practical. I won't say it's the way to heat your house. There are people that do it, but we match the larger systems predominantly, with applications where I think it makes sense to do it. Now, composting was not a household word when I started doing this work 30 plus years ago. Carbon dioxide levels in the air were 330 parts per million. When I became aware what ppm meant. So now that composting is a household word, that it's utilized internationally, there's massive composting facilities and hundreds of them in the Commonwealth of Massachusetts. Some of these are good candidates for integrated heat recovery and CO2 capture. And the more sophisticated the systems get, they also can be very, very down and dirty, very small scale, but they all have a common element, which is there's things that are rotting, there's CO2 that's being liberated, there's heat that's being produced, and if it's not done right, it's going to get shut down by the neighbors, and it's going to cost more money than people think to do it right. So we'd like to have simple but elegant systems that enable heat capture, CO2 recycling, and year-round composting to take place with the minimum of fossil fuel. Systems that are ubiquitous in this country are being replaced by systems that are imported from other parts of the world where composting has taken place for many more decades. It's a particularly nice system I checked out in Germany that they had the whole enclosed composting system inside a very beautiful industrial building. Some of the cool equipment that's out there are rotating drums. These drums are about from here through the end of that wall. And there's systems like this that rapidly accelerate the composting process. So within 3 days, what you put in the front end comes out fairly cool. It's not finished compost, but it's released most of its heat. So in a small footprint with an electrically powered system, you can have a very high yield of compost and heat. So it's a bioenergy furnace. We've designed a system to be installed at the Franklin Park Zoo, did a feasibility study with money from the Massachusetts Clean Energy Center that shows how that system would fit on the footprint, how much it would cost, how much compost would be made. We're quite a ways from actually constructing it, but we've at least advanced the notion and determined that with the right factors that line up, it could be economically viable. We have received a $75,000 grant from the Massachusetts Department of Agriculture to do a compost heated greenhouse at or near our composting site that we run for the City of Boston. So we hope to be implementing that this spring. Again, we will have to lobby the Public Works Department and the City of Boston to allow for a more progressive use of the site than just turning leaves into compost. But we have most of the components already lined up, most of the design, and most of the money. So projects that are cutting edge or outside of the envelope, push the boundaries of the possible, are not easy. They are they can take years and years and do not always get implemented. But we think we have enough of the factors for what we call the Ecovation Center in Mattapan that we'll be able to construct that this spring. I would love to be building this, the facility of my dreams at this site. I don't think that's going to happen anytime soon. But again, I didn't think that there would be thousands and thousands of wind farms, photovoltaics on rooftops, and ecosystem design that is being implemented on a wide scale throughout the United States, throughout the world, things that were only in dream form 25 and 35 years ago. They're happening now. And if you don't put the vision out, don't push for the dream, it will not happen. So thank you very much. And